Welcome back. So today I wanted to do a really cool project, which actually I got inspired by from Matt Parker, who does stand up maths, and it's all about mapping or actually graphing your data whenever you have different data that you're looking at. And more specifically, when you're looking at statistical information, such as the mean or the average, and like standard deviation. Those are the two I'm going to look at today. And just showing that a certain data set can have the same statistical footprint, but it could look very different. So for example, I'm going to show you this program, and it can take a few different types of inputs. So first we can just run the program, and it has some defaults. So what we can see when we first start it is that there's this graph that pops up, and it has all of our data plotted, and this is just random data points. And up here we can see that the x mean is 4.86, the y mean is 5.06, the x standard deviation is 2.85, and the y standard deviation is 2.75. This means if you group up just all of the points and grab just their x values, that's how you get the mean. So you average that, you get the mean, and if you get standard deviation, then that's with the 2.85. And then the same thing for the y, except it's just all of the y values. Now, the way I have this worked out is when I close this window, it's going to open up a new window. And you'll see that there's now a new x mean, y mean, and so forth. So what I've done at this point is I've captured what these statistical metrics were. And then I try to create data. Then I try to create data that is in an X shape that matches that same statistical information. But obviously the data is all skewed and different because now it looks like an X. So if you were to look at just the statistical information from both of these data sets and not have graphed it, you could come to the conclusion that they're the same. However, when you actually graph it, you see that they are vastly different. The way I'm able to mock that is just by making a picture. However, this could be actual different sets of random data. It's just easier to see with a picture involved. Now, if I actually add a number to it as the first parameter, you'll see up here that the number of data points was 100. So this will actually change it to 300. So again, if I close this, then we can see that we now have 300 points involved in all of this. If I add another, then this will show the max x and max y axis. So I forgot what the other one was, but now it'll be 4. So 0 to 4 and 0 to 4. Then if I add another one, this would be how precise it is. So if you see, I go to 2 decimal places. If I want to go to 3, then I can do that. We showed that we've gone to 3. And you can see that there. I can also go to 1. So that allows you to play a little bit with how precise and what the picture is going to look like and all of that, just to do a little bit more testing or playing around. So if we go to the code, we're doing this in Python, as you could already see. We've imported some different libraries. This pyplot, that's how I actually initiate the chart. Random gives us my random stuff. We have some math, and then the sys, which stands for system. That is so I can grab the parameters from the user input. So actually, I'm going to go to the bottom. When we come into this program, since all of these above here are functions because they're delineated with def, then none of those get run unless they're called. So we start here with an if and else. So if we get the length of the argv, which is going to be how it's the array of inputs or parameters on the command line. So if there's only one, that means I just have the graph data.py. There's no other number after that. So I give it all defaults. We'll talk about what those defaults are here. Well, I can just say it. So the first one is going to be how many data points to plot. The second one is the x minimum. Then we have the x maximum, the y minimum, the y maximum, and then the precision. So how many decimal points I want to compare to. And as you can see, these are all the same function that I'm calling, with just variations of what data is defaulted and not defaulted. Yes, I can somewhat take in minimums less than 0. However, just for ease of what I'm trying to show, I always default it to 0. It gets kind of funky when you include negatives, and so that can be a great place for you guys to take it on and maybe make it a little bit more robust in how it handles negatives. So it's not just the top right, top right quadrant. It could be the other 3 as well. But for what I'm working on, it's just going to be the top right quadrant. So as we saw, if we have none, it automatically has everything defaulted. If we do give one input, that's just going to be the data point, how many data points there are. If I give 2, the first one is going to be the data point. Then the second is going to give me my maximums with precision of default 2. And then if I give it technically 4 inputs but 3 numbers, then it's going to be, again, the first one is the how many data points there are. We default the minimums. The second one is going to be the maximums for the x and the y. And then we have our precision. So if we go to display random and created data, we see that we have 5 different parameters. So it takes in num of data points. So it's going to be the number of the data points. The x minimum, x max, y min, y max. Oh, sorry, and precision, which is what we just talked about. So that filters down in. We grab the data points. And so we're going to generate just random data points by passing in all of that information we just got. Then we will go and look at the data statistics. So I will pass in the information that I get from data points. I'm going to pass in the x, min, max, y, all that kind of stuff. X and y mins and maxes and precision. That'll give me an array of data statistics. And then I can print that out. I will then create the chart with those data points. Then I'm going to get the new data points by calling the create x chart. So this is where I take those original points and I'm going to morph them by passing in the data statistics, the data points, and how precise I want it to be. Those will obviously then give me the new data points, and I will then get new data statistics by passing those in. I can print those out, and then I will create the chart and print that out. So moving upward, we'll start then from here. What's from the top? So creating the chart. We pass in an XY list. And what the XY list is a list of data points with the X values being in their own array, which is index 0, and Y values are in their own array of index 1. So this is actually a 2D array. We have an XY list is an array of size 2, with then inside of each of those arrays however many X and Y points we have. So we pass in all of the X values, we pass in all of the Y values. We're going to label them dots, give them the color of green. All this, obviously, all this stuff you can change. The marker, we just give it the period. You can give it a whole bunch of different things, a star, I think the plus sign. You can give a whole bunch of different symbols in there. And this is the size of whichever marker you're giving it. We can name the x-axis. In this case, it's just generic x-axis, y-axis, give it a title. We're going to call it graph the data, and then we show the data, or show the chart. In order to generate the random data, we take in the 5 parameters here, num of data points, x min, x max, y min, y max. It is going to return a 2D array with index 0 being all the x points and index 1 being all the y points. So we pass in however many points we want to get out of this, the min and the maxes. We create 2 empty arrays to start. We cycle through and we give it the range, so it's going to start with 0. By doing this with the range, it's going to give it from 0 to whatever your max number is. Hence why we give it the num of data points. And x will be the iterator through that. So it'll go 0, 1, 2, 3, all the way up. And we know that temp x, we're going to append to that array. We're going to take the random uniform, which will give us a decimal. We're going to pass in the x min and the x max, so that gives us what range we want to give, that we want the decimal to come back in. Then we're going to round it to 5 decimal places. Yes, I could bring in the precision point here. The precision was really for the data statistics, not for my actual original data. So feel free to take that however and change that the way you want. And then I just return a simple array of these 2 arrays, so x and the y. Then for calculate data statistics, I'm going to pass in all that data we just got from the generate random data. And obviously all of this is happening down here. So when I say that calculate data statistics, we already got the data points, and I just pass that in. So I pass in that data. Again, I give it the x min, max, y min, y max, the precision, and it's going to return an array of data statistics. And that will include how many data points there are, the x mean, or average, the y mean, again, or average, the x standard deviation, the y standard deviation, and then I just do pass along these through it as well, the x min max, y min max, and then the x middle and the y middle. I was trying to work on the negatives a little bit, and so really what this was trying to do is to compensate for that, but basically this will give you whatever the middle of your range is. For instance, though, if you have, let's say your x max is 2 and your x min is -2. Again, I don't really take into account for this. I was trying to, but time was getting away from me. But if you get the range, then that's going to be 0. Because you have 2 minus, actually it's going to be 4. So it'll be 2 minus -2 to get you your range, which gives you 4. However, that messes things up for actually getting the true middle of what that graph should be. So yeah, so this does work for what we're working on. If you're going to use negatives, some of this needs to get, you need to add some more logic for that. So we go through and we get the data size, which is just going to be the length of one of the data entries, and one of the data arrays. I could check both, but in this I know that they're going to be added equally. So I just I check one of them. The mean and the means I set to 0, and so as well as the standard deviations. So the first thing we need to do is, if the data size is less than or equal to 10, then actually show what all the data points are. Otherwise, it just gets too big and it messes. It's a lot in the console, so we just don't need to show all of that. Then I go through the range in order to get the mean. So as I cycle through the whole data set, I grab from 0, and that's going to give us the x mean, and I grab from 1, index 1 to get the y mean. So I add all of that up, and that's going to sum up all of those values. And then I have to take that sum and divide it by the data size to whatever precision we're looking for, which is why we have the rounding here. So at this point now I have the x mean and the y mean. Now I need to get the standard deviation. So I now need to cycle through And you can look up what the standard deviation calculation, but once you've taken the mean, then you have to go through each of the data points. So for this case, we're going to start with x. So we're going to get that data point. We're going to subtract it. We're going to subtract the mean from it to see how far away from the mean it is. And then we will square it. And we will get a summation of all of those data points, how far they are away from the mean, and squaring it. Same thing with y. And then we will take the summation of all of that, divide it by the data size, and then we get the square root of that. And then I just round it to whatever precision we want. And it happens with both x and y. And then to get the middle y, what I'm doing is I just get the absolute value of x max, the x min, I add them together, and then divide it by 2, and add the x min and the y min. Again, this is a little bit of remnants of me trying to troubleshoot some of the stuff dealing with negatives. So this does work for the quadrant that I'm working on, the top right, but this is going to need to get reworked and add some logic to it in order for it to work in the other quadrants, in order to use negatives. Then I just return an array of all of those values. Then we create the x chart. So in this case, like I showed, I'm only creating an x image. You can do a lot of different other ones. Someone did a dinosaur, smiley faces, stars, other line segments. I think it'd be a cool thing to do if you could input like a file picture and then it could start to recreate that. But for this project, I just wanted a basic showing what you could do with this and how this idea applies. So the parameters take in the data statistics, the data points, and the precision. So at this point, what we want to do is we kind of don't care really about the original points. However, we use them as a starting block. But the whole point is we want to create a new data set that matches the data statistics. So I just create this temp data points from the data points that came in. We have a y mean step of 0.1 and a y standard deviation step of 0.1. That'll be more evident of why we need that in a second. We cycle through all the data points that we already have, and all we're going to do is we're going to take the x value, and we're not going to change it, but we're going to use that to help calculate what our y value is going to be. So what this all is talking about, we'll talk about this section first. We take the first point, the x value of it, and if it's less than data statistics index 9, which if we count this, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is that middle. So if it's less than half, and if the y is less than the y's half, so if we look at 10, then we know that for our picture, it is going to be in the bottom left part of that picture. So we're still in the first quadrant, but if you split that quadrant up again, then it'd be the bottom left. And if it is, so if it's that, or if it is in the top right corner, meaning that the x is greater than the half mark, and that the y is greater than the half mark, then we know it's going to be a positive slope. So to understand more of what I'm talking about, let's run it. So we're talking about taking this part of the graph and looking at these points of the graph, and we're just going to affect their y coordinate. And then the second part here is going to look at this part of the graph and this part of the graph, and it's going to give us a negative slope. So if I close it, all we did was all the points that were in here, we gave them a value that is going to match a positive slope line. All the points here, we made go over here. The same thing for the other quadrants. So that's what this does. It makes an x. And more specifically, if I comment this out, it's an actual straight line like that. However, if you notice, our x's are fine. The y's are off a little bit. So that's off by 0.01. And then my y deviation is off by more than that. So as you can tell, this part of the code handles the rest. So don't have to worry about X at all. We just need to go and change Y a little bit. So we start with changing the Y's mean. And what we do is we create a while loop. And we already know what the data statistics is 2. So we go up here, 0, 1, 2. We have the Y mean. We know what it needs to equal. So while it doesn't equal that, and we're going to actually call calculate data statistics on the current temp data points, and we're going to get the second value, so it matches up with this. So while those do not match, we're going to keep running this part. And then we have to actually grab what the Y mean is again. So it's a little redundant. I'm sure there's a better way to optimize that, but we're just worried about getting it to work. So we run that again, get the second end to C. We have and then we want to get a temp index. So we want to randomly just grab a point. We don't care which one it is. It just needs to be within the right range. So if you use rand range, then that actually gives you a whole number and not a float point or a decimal. And we know how many maximum points we have, which is data statistics 0, as here, data size, and we just subtract it by 1 since we start with 0. So we grab that random, and if the Y mean is less than the data statistics of the mean, and that the specific point we're looking at, the Y value of it, if we add the Y mean step, which is up here, and it is less than what the max is, 0, 1, 2, 3, 4, 5, 6, 7, 8, so as long as it's less than that, then we will add it to it, because we don't want to go outside of our bounds. Else, so if it doesn't meet that, then we just check, hey, if we subtract the Y mean step, and that's greater than the minimum, then, and so as long as that's still above it, then we will subtract it. Because again, we just want to make sure we're staying in bounds. So if I show you, if I comment this part out, then we can see there's a little bit of blurring, if you will, in the X picture. It's not as crisp. And then we can see now, again, our X means and X standard deviations equal. And now our Y mean equals. And the only one that doesn't equal is our Y standard deviation. So we're off just a little bit. So if we uncomment that, then all we need to do is just change it just a bit so that we can get those to match. So the whole point of standard deviation is to see how close or far apart the points are from each other. So are they really spread out or are they really close together? So again, we're kind of going to do the same thing we have here, except we're going to use it with obviously the Y standard deviation. So as long as the standard deviation that we want does not equal the standard deviation that we currently have for this data set, then we're going to keep cycling through this. And Y standard deviation, then we have to go and grab it. So we calculate data statistics and the fourth value. Obviously that gives us a Y standard deviation. We then want 2 random points because we want to either take 2 points and bring them closer together or bring them further apart. So then if the first index point is equal to the second one, then we just add 1 to the second point. So that's just the index of it. And then we never get values of the same. We always will have 2 different Y values. So then if the Y standard deviation is less than what we want, then we will take the first point. Well, we check, is the first point less than the second point? If so, then we double check to see, or we check to see if the first point minus the standard deviation step is going to be greater than the minimum. And that if we take the second one and we add the standard deviation step, that it's going to be less than the max. So again, so at this point we want to spread the points apart. We know that the first index is less than the second one. And so now we will just take that first point and we will subtract the standard deviation step, which is what we had up here, that 0.1. So you can change that and do what you want with it. And then we add 1 to the second, or add 0.1 to the second. So now we've separated those points out. We go through and we check again. So in this case, if the second point So that's if the first point is less than the second point. Otherwise, either they equal or the second point is less than the first point, then we're going to do the same thing. We're just going to switch it up. So we now just double check to see if the second point minus the y standard deviation is still greater than the minimum. And we see if the first point plus the standard deviation step is less than the max. And we will then take the second one and subtract from it, take the first one and add to it. Same thing, just kind of flip it around in case the points were in different orders. So we just want to make sure that we're moving them apart. We want to move them apart, or move them together when we want to move them together. So if the standard deviation is greater than what the statistic tell us, or that we want, then we want to make it smaller, obviously, and bring them closer together. So if the first point is less than the second point, and we are going to add to the first point and subtract from the second point, so we make sure that they are still within our range, then we will add and we'll subtract. And then if the second one is if the second one is smaller than the first one, then we jump down and just make sure that adding and subtracting to it will keep us in the range, and then we do that. So if we get to points where adding or subtracting won't get us into in the range, then basically we just skip it and we go all the way through and run the loop again. So all that happens many times. We inch closer, and when we finally get there, we return the temp data points. So that's what creating the X chart does, which is what we call right here. And that is how we do this program. So it's a really cool idea. Always make sure that you're graphing your data to really see what it's trying to show you. You may find that it could be a picture, or maybe it's not. But it may show you how your data is differing even when you may have the same statistical information about it. Feel free, and I'll link in the bottom the video that inspired me to do this. I want to give them full credit. There's a lot of research that's gone into this. This is just scratching the surface and just getting people interested in it, and it just itched my my want to kind of play around with it. Have fun, and let me see what you do with it. Like and subscribe. Thanks.